Hello everyone, welcome to the signal system class. In the previous lecture, we discussed the initial value theorem in Z transform. Today we will discuss the final value theorem in Z transform. The final value theorem states that if the Z transform of ft is equal to fz, then limit of ft when t tends to infinity will be equal to limit of z minus 1 times of fz when z tends to 1. So let us see the proof of this theorem. By shifting theorem, we know that limit of z ft plus t when z tends to 1 minus limit of z ft when z tends to 1 will be equal to limit of z fz minus z f0 minus fz when z tends to 1. We know that the z transform of ft plus t is equal to z fz minus z f0. This is shifting theorem, and we also know that the z transform of ft is fz. So we can simplify this as limit of z minus 1 times of fz minus z times of f0 when z tends to 1. So this can be written as limit z minus 1 times of fz minus f0 when z tends to 1. That is, we have substituted the value of z is equal to 1 here, so that this comes out to be f0. And let us suppose that this is equation number 1. Now, from the definition of Z transform, we can write Z transform of ft plus t minus Z transform of ft will be equal to summation n is equal to 0 to k when k tends to infinity of f n plus 1 t z to the power minus n minus summation n is equal to 0 to k tends to infinity f n t z to the power minus n, because the Z transform of ft plus t will be equal to summation n is equal to 0 to k f n plus 1 t z minus n, and Z transform of ft will be equal to f n t z to the power minus n. Now let z tends to 1. So we can write the above equation as limit of z f t plus t when z tends to 1 minus limit of z f t when z tends to 1 will be equal to summation n is equal to 0 to k f of n plus 1 t when k tends to infinity minus summation n is equal to 0 to k f of n t when k tends to infinity. That is, we have substituted the value of z is equal to 1 because we have supposed let z tends to 1. So we will substitute the value of z is equal to 1 in this equation, which comes out to be summation f n plus 1 t minus summation f of n t. Now substituting the different values of n from 0 to k, we can write this as f of t minus f of 0 plus f of 2t minus f of t plus f of 3t minus f of 2t plus f of kt minus f of k minus 1t plus f of k plus 1t minus f of kt. Here we find that all the terms will cancel out except the term minus f0 and fk plus 1t. So this equation gets simplified to fk plus 1t minus f0 when k tends to infinity. If we substitute the value of k tends to infinity in this equation, we can write this as f infinity minus f0. Let us suppose this equation as equation number 2. Now comparing the equation 1 derived earlier and this equation, we have f infinity minus f0 will be equal to limit of z minus 1 fz when z tends to 1 minus f of 0. Now this f0 and this f0 will cancel out. So this equation will come out to be f infinity is equal to limit of z tends to 1 z minus 1 times of fz. Now we can write f infinity as limit of ft when t tends to infinity will be equal to limit of z minus 1 times of fz when z tends to 1. This is the final value theorem. So we have proved this theorem. So that's all in this presentation. See you in the next presentation.